Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat pagi, salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning, ladies and gentlemen. His Honorable Mr. Mark McCranigan, representative of the Global Power System Transformation, and the Honorable Delegate from UNOPS, the Honorable Delegate from Asian Development Bank, the Honorable Board of Commissioner of PT PLN Persero, His Honorable Bapak Zulkifli Zaini as President Director, Bapak Haryanto WS as Regional Business Director of Jaffa, Madura, and Bali, and all Board of Director of PT PLN Persero. The Honorable all speaker from GBST and distinguished as EVP, EVP, GM, Board of Director of subsidiary company, and all senior leader in PLN Group. Ladies and gentlemen, welcome to Power System Sharing Series. My name is Mahani. It is a wonderful and precious opportunity for me to be your master of ceremony for today. We really appreciate your time for attending and participating to this event. This sharing session will be supported by the international speaker and expert in power system who already have high experience in power system. Be informed as well that this event will be held in 10 series with various topics in connection with power system. Okay, before we go through to our main agenda, I will invite you all for taking picture together, and please hold the two thumbs up like this and show your best smile. Mohon izin Bapak Ibu untuk foto bersama terlebih dahulu. Ya, please hold in 10 seconds. Okay, get ready. Let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, finish. Very good. Thank you very much. Okay, ladies and gentlemen, to begin this sharing session, we would like to invite Bapak Haryanto WS as our Regional Business Director of Jaffa, Madura, and Bali as the host of this event to deliver the opening remarks. For Bapak Haryanto WS, the time is yours, Pak.
Thank you, terima kasih Mani. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Om Swastiastu. His Honorable Mr. Mark McCranagan, a representative of Global Power System Transformation Consortium. Very good morning. Yang kami hormati Bapak Direktur Utama PT PLN Persero, Pak Jul. Yang kami hormati jajaran Direksi PT PLN Persero. The honorable speakers from CHAISO and REL, and also the bar consultant, Mr. Oscar and Francisco de Lima. And especially selamat malam Pak Dede Subakti dari CHAISO, serta para hadirin sekalian dari ADB, serta Bapak Ibu, SIVP, EVP, GM, dan semua PLNers yang saya cintai, saya banggakan. Pertama-tama mari kita panjatkan puji dan syukur kehadirat Tuhan Yang Maha Kuasa, karena rahmat dan karunia-Nya pada hari ini kita dapat bertemu dalam rangka Power System Sharing Series melalui webinar PLN GPST Cooperation serta peresmian Power System Operation Forum di PT PLN Persero. Pada kesempatan ini kami selaku host menyampaikan ucapan terima kasih kepada Bapak Direktur Utama PLN yang telah bersedia membuka acara webinar ini, serta para peserta webinar sekalian. Terima kasih atas kehadirannya. Wabil khusus terima kasih Bu Cynthia, Pak Teguh, Pak Suroso, Pak Riyadi, Pak Eko yang telah mengatur acara kita hari ini. As the host, I would like to say welcome and thank you to all speakers, especially to the team from GBST from various parts of the world. I would like to express our gratitude to GPST Consortium for this cooperation, as well as Mr. Mark McGranagan, who will also give an opening speech on behalf of GPST Consortium. We would like also express our gratitude and appreciation to all speakers at the technical session. Teman sekalian, Bapak sekalian, kita harus bangga dan besar hati karena pada kesempatan ini diberikan waktu untuk mendapatkan tambahan wawasan ilmu dan pengalaman dari komunitas power system berskala internasional, baik dari perusahaan listrik maupun lembaga penelitian terkemuka di dunia. Dalam kaitannya dengan transformasi di PLN, saat ini ada 2 breakthrough program yang secara langsung mendukung peningkatan kinerja operasi sistem, yaitu anti-blackout dan dispatch optimization. Salah satu inisiatif strategik yang dilakukan yaitu upgrade Jawa Bali Control Center menjadi Advanced Control Center yang bertujuan untuk meningkatkan kemampuan P2B dalam pengelola sistem Jawa Bali untuk tetap bisa menjaga keandalan serta keekonomian sistem, terutama dalam mengatasi kendala end of life atau obsolete-nya dari sistem existing, mengantisipasi perkembangan teknologi, serta menjawab tantangan akan beroperasinya EBT intermittent seperti PLTS dan PLTB dalam waktu dekat. Di samping itu, ada inisiatif strategis lainnya berupa program peningkatan jumlah pembangkit yang aktif secara free governor yang merupakan pengaturan primer serta automatic generation control sebagai pengaturan sekundernya. Hal ini secara signifikan akan meningkatkan peran pembangkit secara aktif untuk turut menjaga kestabilan sistem. Di samping itu, perkuatan proteksi sistem dengan penerapan adaptive defense scheme, serta uji host load dan black start dan line charging menjadi program andalan untuk meminimalkan risiko gangguan meluas, serta untuk mempercepat penormalan sistem pasca gangguan. Tetapi hal tersebut akan sulit terlaksana jika tidak didukung kompetensi mumpuni dari para engineer power system yang ada di PLN. Untuk itu, acara webinar Power System Sharing Series atas kerjasama PLN dengan GPST ini menjadi sangat penting dan strategis sebagai program capacity building bagi para pengelola sistem, baik yang ada di Jawa Bali, Sumatera, Sulawesi, Kalimantan, dan Nusa Tenggara. Bapak Ibu yang kami hormati, forum yang baik ini kami harapkan dapat berguna untuk membentuk komunitas power system operation di internal PLN, serta melalui GPST menjadi jembatan kerjasama dengan komunitas yang ada di dunia internasional. Dengan adanya Power System Sharing Series yang direncanakan terdiri dari 10 serangkaian ini, kami harapkan dapat terjawab berbagai pertanyaan maupun permasalahan yang selama ini menjadi kendala bagi para insan Power System Operation di Indonesia, dengan tambahan wawasan ilmu maupun pengalaman dari para praktisi dan peneliti power system di dunia internasional. Di samping itu, ajang webinar ini kami harapkan dapat dimanfaatkan untuk meningkatkan komunikasi, kerjasama, serta knowledge sharing di internal pengelola operation system di PLN, melalui sesi knowledge sharing internal secara bergantian dari setiap unit pelaksana yang mengoperasikan control center. Hal ini pada akhirnya akan mendukung program transformasi PLN Beyond Generation yang lean, inovatif, dan customer focus. Finally, on behalf of the host of this webinar event, I would like to thanks to Global Power System Transformation Consortium, along with all other speakers, for their willingness to provide capacity building for the Power System Operation Engineer at PLN. Semoga kerjasama ini mendapatkan ridho dari Tuhan Yang Maha Kuasa dan memberikan manfaat yang sebesar-besarnya bagi PLN dalam upaya melistriki seluruh masyarakat Indonesia. Terima kasih. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih and thank you Pak Bapak Haryanto WS for the opening remarks. Before we jump into the next agenda, we would like to present PLN company profile in a video which already prepared by our team. Please enjoy the video.
Kami tumbuh atas dasar kecintaan terhadap negeri ini, Republik Indonesia. Kami terus berupaya mewujudkan keadilan energi untuk seluruh rakyat Indonesia. Dengan menghadirkan listrik hingga ke seluruh pelosok negeri. Kami membangun infrastruktur untuk melistriki daerah tertinggal, terdepan, dan terluar. Dengan mendorong penggunaan energi ramah lingkungan seperti pembangkit listrik tenaga surya, pembangkit listrik tenaga panas bumi, dan pembangkit listrik tenaga air. "75 tahun PLN hadir dan terus berkembang. Memberikan pelayanan kepada 77,7 juta pelanggan. Dengan kapasitas pembangkit listrik mencapai 63.208 MW, panjang transmisi hingga 60.345 km sirkuit. Dan total nilai aset sebesar 1.600 triliun rupiah yang tersebar di seluruh Indonesia. Sebagai badan usaha milik negara, PLN senantiasa berkontribusi meningkatkan ketahanan ekonomi melalui peningkatan pajak dan dividen untuk kemajuan bangsa. Komitmen PLN untuk meningkatkan pelayanan kepada pelanggan juga dibuktikan melalui kenaikan peringkat kemudahan mendapatkan listrik. Kini, dunia membutuhkan solusi untuk tantangan baru di masa depan. Dan PLN berupaya memastikan kegiatan usaha yang berbasis wawasan lingkungan. Hal ini dibuktikan dengan perolehan proper emas selama 3 tahun berturut-turut.
Selama 75 tahun, PLN telah menghadapi berbagai tantangan untuk melistriki tanah air. Dengan aspirasi seluruh insan, PLN terus bergerak maju dengan melakukan transformasi guna menyiapkan kebutuhan listrik masa depan. Power beyond generation. Pertama, PLN akan lebih green, memanfaatkan energi baru terbarukan yang ramah lingkungan demi generasi masa depan. Kedua, zaman terus bergerak. Kami harus kreatif dan solutif agar semakin inovatif. PLN mendigitalisasi semua proses bisnis dan operasi. Ketiga, kami semakin bertumbuh, lincah dan gesit. Kami lean. Dan keempat, PLN berorientasi pada customer focus agar pelanggan semakin terintegrasi dan menikmati layanan PLN. Transformasi power beyond generation. memberi suntikan energi insan PLN untuk memberikan yang terbaik
ekonomi bangsa dan kesehatan seluruh rakyat Indonesia. Melalui 4 pilar, yaitu peningkatan penggunaan pembangkit yang ramah lingkungan, mendorong pertumbuhan melalui model bisnis dan layanan yang inovatif, lincah dan gesit, PLN Lean di semua lini proses, dan customer focus, meningkatkan pelayanan lewat pendekatan berbasis teknologi. PLN bertransformasi untuk menjawab tantangan di masa depan dan percaya sepenuhnya pada potensi insani. Didukung 11 entitas anak perusahaan, PLN berkomitmen selalu mengedepankan layanan terbaik untuk pelanggan. Pencapaian kesuksesan PLN selama 75 tahun adalah hasil dari kerja keras semua insan PLN, dukungan penuh dari pemerintah, dan kepercayaan konsumen. PLN akan selalu terus bertumbuh secara berkelanjutan, memegang amanat untuk menerangi dan memastikan ketersediaan listrik bagi bangsa Indonesia. Demi masa depan Indonesia yang terang dan gemilang.
I hope you enjoy the video. And the next agenda is a speech from our President Director, Bapak Zulkifli Zaini. For Bapak Zulkifli Zaini, the time is yours, Pak.
Terima kasih, Mbak Mahani. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Salam sejahtera untuk kita semua. Salam. Om Swastiastu, Namo Buddhaya, salam kebajikan. Good afternoon, good morning. His Honorable Mr. Mark McGranahan, representative of GPST. Very good morning.
Good morning.
Board of Director of PTPL and Pesero, honorable speakers from GPST members, PPRI, and REL, CAISO, and also Mr. Oscar and Francisco de Lima, AVP, GM, BODs of PLN subsidiaries, and distinguished guests, ladies and gentlemen. First of all, let us praise to the presence of merciful God who has bestowed our pleasure for health, opportunities, and happiness we have today, and His grace on this day, so we can meet in this scheduled PLN GPST Corporation webinar, Power System Sharing Series, and the inauguration of PTPLN Pesero Power System Operation Forum. Ladies and gentlemen, on this occasion, we would like to convey that, as we all aware, around 60 to 70% of PLN electricity costs comes from fuel. The efficiency of fuel consumption is determined by the dispatcher's performance in the control center in optimizing the low-cost generation while maintaining continuity, reliability, and quality of electricity supply. Other factor is development and technology innovations. Several intermittent new renewable energy has been operating in Indonesia power system, such as in Sulawesi and Nusa Tenggara. In the next few years, intermittent new renewable energy penetration
will also come in the Java Valley, Sumatra, and Kalimantan system. Furthermore, it is necessary to increase the dispatcher technical competencies to enhance their knowledge and skills, including the power system engineers who support the system operation through planning studies, analysis of operational evaluation as the business process of a power system. Ladies and gentlemen, Alhamdulillah, it is being piloted, cooperation between PLN and Global Power System Transformation, GPST, a non-profit consortium of various international electricity stakeholders, that is the international system operator, utilities such as CAISO, ERCOT, IMO, EnergyNet, National Grid, ISO, International Research Institute, IEEE, and NRAL, APRI, CSIE, international universities such as Imperial College of London and DTU, as well as International of Regional Energy Southeast Asia, ACE, Asian Center of Energy. We should be optimizing to utilize this opportunity to improve the power system operation engineers' technical competency that are all around Indonesia by learning from world-leading electricity companies' knowledge and experience. Undoubtedly, our ambition is to become the leading electricity company in Southeast Asia and the customer #1 choice for energy solution is about to materialize. We are very grateful to have this forum to oversee the Advanced Control System, ACC, development process in Java Valley system, which is planned to start operating at the end of 2023, which currently powers around 70% of PLN customer in Indonesia. The existence of this ACC is expected to be able to support pay-to-B target, become one of the leading grid operators in Southeast Asia that can adapt to technological advances, demand of customer needs, as well as the era of electric vehicle and intermittent new renewable energy. That is something unavoidable. The power system sharing plan to consist of 10 series contain additional insight on technological and scientific development in the electricity sector and knowledge sharing from electricity practitioners in the world, especially those who have experience to anticipate intermittent new renewable energy penetration in their electricity power system. This webinar will also improve communication, cooperation, collaboration, and knowledge sharing in international system operation managers as PLN through the Power System Operation Forum inauguration. There will be also internal knowledge sharing session in each webinar from each PLN unit that operate the control center to support the lean, green, innovative, and customer focus as the 4 pillars of PLN Beyond Generation Transformation Program. Ladies and gentlemen, finally, on behalf of the PLN Board of Directors, we would like to thank the GPST Consortium, EPRI, NREL, CAISO, and the BAR Consulting for their willingness to provide capacity building to the power system operation engineers of PLN. Hopefully, this first collaboration in sharing session will continue to enhance the knowledge, skill, awareness, and lesson learned that can be learned by PLN engineers and provide more benefit for both parties, whereas last but not least, also to support PLN sustainability to provide electricity to all people in Indonesia. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih. Thank you very much, Bapak Zulkifli Zaini, for the welcoming speech. And the next agenda is speech from a representative of the Global Power System Transformation, or GPST, for Mr. McGranigan. The time is yours.
Okay, thank you very much. And I want to also thank CEO Zulkifli Zaini for a very inspiring opening speech. I think the pillars of a customer focus and a lean, green, and innovative company are exactly right on. And I look forward to being able to work with PLN to help make that happen. Let me try to share my screen briefly here. Share. Just for this one slide. Okay, how's that work? I wanted to provide a very quick welcome from the Global Power System Transformation Consortium that is helping to sponsor this webinar. This is, as we've heard from CEO Zaini and from Herianto, my friend from many years ago, working on reliability of the distribution system in Java. That was a great project. The Global Power System Transformation is a effort that was organized by some of the leading system operators around the world, along with
slideshow, so get a bigger picture, please.
Oh, let's see, do I need, let's see, and show.
Okay.
Just do it this way.
Yeah, slideshow then.
Is that okay?
No, slideshow then, please. Yeah.
Oh, yes.
Yes, that's it. Okay, then you pick the up the use slideshow.
Just switch screens maybe, or.
Yeah. Yeah.
That's great.
Thanks a lot.
Okay. Yeah, so the Global Power System Transformation was brought together by some of the leading system operators and also leading research organizations, but with a very strong focus to learn from these organizations and transfer that knowledge and interact with other leading utilities from around the world to share knowledge and learn from each other. And this is one of the first examples of that information sharing and two-way learning between the GPST consortium members and organizations like PLN around the world. So thank you very much to PLN for helping make this information sharing exercise a reality, because we learn from each other in this process. So that is one of the main objectives, is to continue to identify the technology needs and research gaps to achieve the goals that CEO Zaini described of having a customer focus and taking advantage of technology to operate the system more reliably and integrate renewables into that process. And the system operation and the control center are key aspects of this goal. So we look forward to this information exchange, and I hope it is a start to a long relationship to continue that process and plug into our research objectives. So thank you very much for this opportunity, and we look forward to the discussion. Thank you.
Thank you.
Okay, thank you very much, Mr. McGranigan, for the speech, and really appreciate it. Now, ladies and gentlemen, the next agenda is the sharing session and discussion, which will be held around 2 hours ahead. The discussion will be led by a moderator, Bapak Dani Barus. First of all, please allow me to introduce the moderator. Currently, Pak Dani is a senior manager in Teknik in PLN Jaffa Bali Control Power System, and his education history. Previously, he obtained a bachelor degree in electrical engineering and master in electrical engineering from Bandung Institute of Technology, and currently he is a candidate of doctoral in electrical engineering from University of Indonesia. Before I offer to Pak Dani, we would like to remind you to fill the attendance list and feedback form via link which shared by our team in the chat box. Without further ado, let's start the discussion today, and I would like to invite Pak Dani. Pak Dani, the time is yours, Pak.
Thank you very much, Ms. Mahani. Good morning, ladies and gentlemen, the Honorable President Director of PLN and Board of Director, PLN President Commissioner, and the Board of Commissioners, GPST speakers and representatives, and all distinguished audience in this webinar. I'm Dani Barus from PLN P2B, will be the moderator during this technical session. I'm very pleased to have you here and welcome all of you to this webinar. The topic of this first Power System Sharing Series is Industry and Researcher Perspective on Control Center Upgrade Procurement. During this session, we will have presentation and Q&A session separately. We will have 5 groups of presenters that will deliver the material in a row. Ladies and gentlemen, our first speaker is Mr. Suroso. Currently, he is the General Manager of PLN P2B Jawa Madura Bali. He has received his bachelor degree at Institute Technology of Bandung and master degree from Dundee University, both in electrical engineering. Mr. Suroso, you have 20 minutes to deliver your presentation. Now, the floor is yours.
Thank you, Pak Dani Barus, as moderator. I will share my presentation. The Honorable CEO of PLN, Mr. Zulkifli Zaini, the Honorable Representative of GPST Consortium, Mr. Mark McGranigan, also the distinguished speakers, ladies and gentlemen, good morning and very good morning and also very good evening for those colleagues from the other side of the world. Thank you for the opportunity today. My name is Suroso Islandar. I'm the General Manager for the Jaffa Bali Control Center at the moment. Allow me to presenting the concept of our advanced control center for the Java Bali Power System, which is we call it the next generation of the control center in Java Madura Bali. To begin with, this is the overview of the Java Bali Power System at the moment. The Java Island is about 1,000 kilometer long, and then we have an interconnected system with the main backbone as depicted here using the 500 kV extra high voltage transmission system. At the moment, the peak load is achieving more than 26,000 megawatt, exactly 26,378 megawatt reached during last week, 24th of March, during the daytime. And the total installed capacity is 37,402 megawatt. The load pattern normally something like this in this right corner, on the top corner, where we have the two peak time during daytime and also during evening time. Our energy mix at the moment mostly served by coal-fired power plant, accounted for about 68% of it. And then next to it is the LNG and gas, and then followed by hydro and also geothermal. As we operating the system of Jaffa Bali, we follow the basic principle of power system operation and control. And probably in this basic power system operation and control principle also followed by other system operator in the world. Basically, at all time, as a grid operator, we have to maintain the operation in such way that fulfill three criteria. The first criteria is the system have to be reliable, which is the system integrity and robustness have to be maintained in any condition, whether it's on steady state condition, transient, and also the robustness against system fault, and as far as possible alleviating the blackout or zero blackout. And then the system has to be operated in good quality, following the voltage and frequency standard stipulated by grid code and all the other parameters as well. And of course, the other aspect, the very important aspect, that the system has to be operated economically. It has to be fulfill the principle of a least cost operation, where we can meet the minimum generation cost in order to provide a very competitive rate of electricity to the public. And of course, coming slowly but sure, that we have to also follow the green standard, that the system have to doing as much as possible to do the energy transition toward a low carbon energy system, which is we have to be environmentally friendly operation. Ladies and gentlemen, at the moment, the existing control center infrastructure of Jaffa Bali, we use the decentralized concept. So at the moment, we have one load dispatch center located in Jakarta, and then we have 5 area control center. And the approach was using this modular and decentralized based on the previous philosophy that the load dispatch center operating the 500 backbone and also doing the energy management system, especially for those power plant connected to the 500 kilovolt system. And then those 5 area control system mainly focusing on the switching of the sub-transmission level, which is 150 kV voltage transmission level, and also 70 kV, and also manage the smaller unit of power plant, which is connected into the 550 kilovolt transmission system. So this is the pictures of our existing control center at the moment. The place of the Jaffa Bali Control Center is named Gandul, so we call it GCC Gandul. And this is our mimic diagram and mimic board at the moment. And there is one area or regional control center, which is focusing on the switching of the Jakarta Metropolitan, and also one in the West Java for the West Java region, located at Bandung City in West Java. And then also one area control center in Central Java, focusing on the switching of 100 kV and 70 kV system on the Central Java transmission network, and also one in East Java, and the last is one in Bali. And why in the background, why we need the new infrastructure of control center into the future? Mainly driven by the existing control center, which has been operated since 2005. will be obsolete at the end of 2021. There is a limitation on the hardware type. At the moment, we are running our master station on the unique Sun Solaris system, which is no longer supported by the manufacturer, and also the operating system to use, including the energy management system. At the moment, we are using the Siemens Spectrum 4, which is very soon no longer supported and also does not have any features which can accommodate more variable renewable energy into the grid. Hence, cannot support the energy transition towards the low carbon energy system in Indonesia. And also has already achieved its maximum capability and also does not have advanced function on the advanced power system application. So our goals and target for this upgrading Jaffa Bali Control Center is basically to achieve the efficiency and the effectiveness of system operation in line with the transformation PLN that we have to be our company which is a very lean, agile in doing operation. So we have to achieve this efficiency and effectiveness basically by simplification of the control center from one Jaffa Bali Control Center and 5 area control center become one main control center and also one backup system or disaster control center in order to optimize the control and the speed up of the recovery of the system in case there is some disturbance into the power system. And also looking ahead from the future landscape that it is coming here, the challenge of the changing of the energy system landscape in Indonesia. First, we have to support the growth of the Jaffa Bali electrical power system, which has enjoyed steady growth at least 6 to 7% annually. And we are looking at the doubling of the peak load during the next 10 years. And also we have to anticipate the penetration of the variable renewable energy, the coming storage system, or any the high voltage DC devices, also FAX devices. The drive into the increasing penetration of the variable renewable energy become one of the primary driver why we have to upgrade our control center infrastructures. And also we are anticipating in the changing in regulation or also business model, the electricity supply industry structure in Indonesia sooner or later will change according to the new business environment and also according to the new regulation stipulated by government. And of course, we are also embracing the Industrial Revolution 4.0 and all its associative disruptive technology. It has come here, the electric vehicle, the rooftop system, and also smart homes, smart meter, and all this new technology, which basically empowering the customer, which is not only doing the consuming the energy, they are also able to a certain degree producing the electricity for themselves. So we are looking at the advanced control center advantage features. We are looking at the master station have to be able to support the variable renewable energy forecasting, which will come here, whether it is the wind farm or solar farm, based on the latest technology such as artificial intelligence. And also the master station have to support the automatic generation control implementation and its integration into production optimization, which is a key factor in doing business, providing very economical electricity to the people. And also it has to support the advanced operator training simulation. The second main feature is the new control center have to support advanced power system analysis, increasing awareness of the dispatcher. So rather than taking corrective action, we can taking the anticipative action. The advanced power system analysis such as the optimal power flow, the dynamic security assessment, and also the wide area monitoring system will improve dispatcher capability doing power flow simulation to optimal power flow in such way so we can take into account all the losses, the economic dispatch, the voltage, and the transmission constraint in order to achieve the secure, the reliable, the quality, and the economic operation of power system. And also improve analysis function within voltage stability in order to anticipate voltage collapse, system stability, instability, transient security, and also small signal analysis system, which sometimes happening on the Jaffa Bali power system. This is some sort of the diagram how the automatic generation control implementation, which has been implemented starting from the several last previous year, although we have not achieved 100% participation in automatic generation control. So the automatic generation control basically doing the economic dispatch and also sending the secondary frequency regulation signal into the power plant, which considering the weather forecast from the weather monitoring system combined with the short-term load forecast and the performance of the SCADA system, and then fed into the optimization general scheduler. We are using JEROS from Siemens at the moment in order to achieve the good merit order and the lowest cost as soon as possible while fulfilling all the constraints, either in the generation or in the transmission or substation side. And also the online dynamic security assessment concept. Basically, we have to increase the situational awareness from the voltage stability analysis tool, transient stability analysis tool, or a small signal analysis tool, which is at the moment happening again and again in our expanded system in Jaffa Bali system. And at the moment, we have quite minimum situational awareness. So sometimes the dispatcher in the control room are quite difficult to anticipate. If there is a dynamic on the supply function, there is a dynamic on the power system operation. Sometimes we caught by a sudden surprise from the big disturbance of the system. For example, last week on the Saturday morning, we have a large disturbance on the eastern side of Jakarta, 1,800 megawatt loss for 2 hours. And that's something that we have to overcome now and in the future. And also we have trying to improve the state estimator based on the phase monitoring unit and wide area monitoring system. We have installed several PMU on the some key bus bar and key substation on the power system. And this is the example on how we trying to process the information taken from those PMU and fed into the state estimator in order to help the dispatcher doing the dispatching more precisely. This is the concept for our advanced control center. From the existing modular and decentralized control center, which is consists of 1 Jaffa Bali control center and 5 regional control center, and change into 1 centralized advanced control center on the western side, probably situated in Jakarta, or depends on the study later on, and 1 disaster recovery control center, which in our view, we will put it on the eastern switching side of the system. So we have still fulfilled the redundancy while maintaining the effectiveness of the operation of the power system. This is the picture of the Jaffa Bali Control Center, and at the moment I am on the 4th floor of this building together with other colleagues, and this was taken on the last beautiful evening of Jakarta. And this is our proposed location for future main control center, which is actually sited next into the existing, and we will connect those 2 buildings using the sky bridge probably, and then we will try as much as possible to utilize the land asset we have at the moment in Gandul, South Jakarta. And also we have identified the location candidate for the future disaster recovery control center. 1 candidate is in East Java province in the city of Surabaya, and we have identified some idle land asset over there, which can build into one new disaster recovery control center. And thanks to the KAISO, thanks to Mr. Hani Alarian, Pak Roberto Bayeti, Pak Didi Subakti, this is taken from the control room in the California ISO. We are very much looking up into the California ISO. So we would like to have our future layout of the main control center, something like this. First, we have the switching dispatcher on the front left side, and then we have the power balancing dispatcher, which is supported by the reliability engineer on their side, and also supported by the energy management system engineer. On the second row, there is a client representative, because whenever a disturbance happens, the level of incoming phone call into the control room is very, very high. And at the moment, we only assign one person, which sometimes cannot answer all those questions. So we would like to have one desk here as the client representative who can communicate it with the whole stakeholder in case there is some crisis happening or if there is some major change happening on the system. And of course, there is a supervisor, the safe coordinator on the central side, and also support from the hardware, the IT and SCAD detail engineers. And this idea basically are taken from inspirement from the KAISO. So we would like to have something probably similar with this. And this is the timeline and the milestone of the Advanced Control Center projects. By end of 2023, or at least on the first quarter 2024, we would like to have the new control center go live. And it has been starting the study from 2009, the feasibility study with PLN Engineering. And at the moment, we are on 2021, we have hired consultant from from Debar, Mr. Oscar De Lima and Francisco De Lima, who will consulting us with the preparation of the bidding document. And then we are preparing to procure the project consultant within next quarter, which is supervising the construction until the end of the progress. And then hopefully by end of this year, we are able to complete the procurement, and then the construction can start. And with the high level target for the integration of SCADA and energy management system up and running by 2022 in such way. So by the end of 2023, we have the new control system of Jaffa Bali running. And of course, there are some issues which have to be mitigated during the Advanced Control Center project transition, which is mainly the transition from the existing decentralized and modular control center into one centralized advanced control center. And we don't have very much time left. End of the life of the existing is 2021. So after that, we will struggle in doing the operation of the Jaffa Bali system. So the risk involves like no application support, and then the overloading of database capacity, and the most important is the obsolete of hardware spare part. So if something happening with the one piece of the hardware, we don't have any replacement. And this poses a very, very great risk into the company operation. Therefore, this has to be speed up in order to save the company operation, to save the Jaffa Bali power operation, and to anticipate the development of the energy system in the future. So as my concluding remark, that PLN, like it or not, ready or not, have to embrace the future. We have to build the modern power system control in order to enable the clean energy transition. As in line with PLN transformation program, to be a green, lean, innovative, and customer-focused company, Jaffa Bali system should be prepared for the change of future energy landscape in Indonesia toward low carbon energy system by upgrading the existing Jaffa Bali control center into an advanced control center. In this sense, in this regard, the help from the global PST Consortium is a great help and a great benefit for us. Because as I see from the vision and mission of the global PST Consortium, and also the operation pillars of this non-profit organization. It will help any existing grid operator who willing to advance and to upgrade its infrastructure. And also looking at the big challenge of the power system, which will move away from the current condition of the dispatchable generation, the non-transmission topology, and forecast for load will change into the future power system, where we have to have capability of forecast for generation, in this case variable renewable energy, and also we have to operate within flexible transmission topology, and also dispatchable load, in this case the demand response or distributed energy resources in anticipation of the flourishing electric vehicle and also rooftop in Jaffa Bali power system. And finally, the main goal is the objective of our system operation as stipulated by government through grid code have to be achieved, which is the power system which can run reliably, quality, economic, and green. Thank you very much, ladies and gentlemen, for your attention. And this is the end of my presentation. I am very happy to welcome all questions, feedback, answer, and also critics for this presentation. Thank you very much. I will pass the time back to Pak Dhani Barus. Thank you.
Okay, thank you very much, Pak Suroso, for giving us such fruitful and interesting presentations. Oke, untuk semua peserta, kami mengingatkan untuk mengisi absensi, feedback, dan pertanyaan melalui link yang sudah di-share di chat room. Untuk pertanyaan, bisa juga langsung ditanyakan di chat room. Jangan lupa dituliskan nama dan unit penanya serta nama tujuan speakernya. Oke, we go to the second speaker. The second speaker will be Mr. Hardison. He works for NREL in Denver, and he leads the GPST engagement with PLN in Indonesia. In addition, he performed project management and research as a member of Research and Sustainability Group in the field of energy resilience and international renewable energy market development. Mr. Rob, you have 10 minutes to deliver your presentation. Now the floor is yours.
Thank you, Pak Dhani. And thank you for that lead-in, Pak Suroso, to kick us off on these presentations. Can everyone hear me okay?
Okay.
Yes.
Okay, that's
Great, thank you.
Please stop.
So I'd like to take a quick step back. First, thank you all for taking the time out of your busy days and busy schedule to join us today. This is a very exciting event for me and for the GPST team. So thank you for taking the time to be here with us and to help this be a successful event. I wanted to take a quick step back to just highlight the status and kind of where the GPST team and PLN are in our ongoing relationship. And then dive into the next bit of my presentation, which will cover get a little bit more technical, not too technical, but a little bit. First, just wanted to let you all know where we are with the ongoing activities that we have with PLN. First and foremost, we're helping to support the procurement for the Java Bali Control Center, as Pak Suroso has just discussed. And the support that we've been providing there is kind of reviewing some of the procurement documents and providing some input into the procurement process. And we hope to continue to be able to do that. And we see this event today as supporting that. And then we're hopeful that PLN will be able to take advantage of the other GPST resources as the procurement continues, and to be able to pull from those and learn from experiences from other members of the GPST program. So we're hopeful to continue that over the coming months and years even. A next big area of focus will be to continue on in this power system sharing series, and looking at the various potential topics that we have listed here. They cover a wide range, and these are just kind of the options that we have. So what we'd like to be able to do is, as we continue to engage with the system operator forum that you all have established to really narrow in on specific topics that are going to be most useful to you as you see it. And then we can really dive into the specific topics that are most valuable to you all. This initial first series that we're doing today, I would say, is likely to be less detailed and less technical than the future ones. The future ones, we really hope to dive in and have some full detailed discussions with staff to really understand what your challenges are and to go beyond just one-way sharing, but also to have a back and forth discussion with PLN staff to learn more about what your challenges are to help inform future discussions. But also you'll notice here that the bullet there that says PLN system operator supporting roadmap, that's a major goal that we'd like to work towards so that we can understand some technical challenges that later down the road we can work to actually do some project work or some studies with PLN to specifically address and support PLN as they work towards these challenges. And another future activity that we hope to build out is a fellowship program that would build on work that's already been done with CAISO. Pat Dede has been a key advocate of that, and we're hoping to be able to build that out further into the future as well. So that kind of summarizes where we are in the relationship now with PLN, and we're hoping to build that out. So to dive a little bit more into the technical aspects of things, I performed an interview with Diren Obadina, who's a doctorate at the ERCOT power system, and that's the Electric Reliability Council of Texas. And he's a principal for the systems development operations there at ERCOT. So we talked through some of the challenges and lessons learned that he had to share based on procurements that they've gone through at ERCOT. We looked both at large-scale procurements that would be kind of a system-wide refurbishment or rebuilding of systems that have happened a long time ago, but then the incremental changes and upgrades that they do for various system components. So he had some insights, and I'll share those with you. But to give you just a little perspective, as of 2019, the ERCOT area, which is the state of Texas, you can see on the map there, that's the state. It covers 90% of the state, and that's 26 million customers and 680 plus generation units, 94 gigawatts of installed capacity. 25% of that is wind, and 23% of that, or sorry, 2.3% of that is utility scale solar. And just recently, their wind penetration record was previously 58%, and just recently, I think they cleared 60% within the past couple of weeks for instantaneous wind penetration. So the types of procurements that they've gone through recently, gone through over their history, as I mentioned, that obviously they've done long or big scale upgrades and replacements, but they've also done smaller incremental ones. Currently, they are going through an upgrade of their EMS system. So we had some direct advice or direct lessons learned from that. And so I broke these down and tried to categorize them into a certain set of components there. And the first one is there in the procurement planning. And this is along the lines, I think, of what Pat Siroso had noted, that one of the main drivers of the procurement cycle is just the obsolescence of kind of the underlying equipment. For them, their underlying Linux operating system will become obsolete in 2024. And they began planning and working towards the replacement of that in 2019. As I mentioned, they're also going through a smaller upgrade for just components of the EMS system, but that cycle is driven largely by the support packages and the contracts that they have in place for those that run on 5 to 7 year cycles. So they typically do significant upgrades for those to ensure that they're up to date and able to operate with the new technology regimes that are out there relatively frequently. Other recommendations that he made on the RFP design considerations was really trying to stay away from customization of the systems that are put in place. He noted that they have 300 customizations as part of their system, and he noted that that's too many to deal with, and a lot of management has to happen with that. And so he has said that if you can try to minimize that, and you can reduce the upfront costs that are entailed with those, but also it helps to reduce the upgrade costs and the amount of time that it takes to replace those systems. He also said to focus on simplicity for the systems you have in place. There were several that they had built into their systems that were just simply, they were good products once they could be used, but in reality, some of them were just too difficult and timely to use, so they never got put to use. So yeah, he said focusing on simplicity of the usability is also very important. He recommended going through a request for information process when you're going through large scale replacements or upgrades. And part of that is to be able to learn from the vendors what their base systems are. And this ties back to the previous point that I made about not having too many different features added on to a base system. So once you go through an RFI, you can learn what it is that each vendor has, and then based on that, really prioritize what PLN sees as their main features that they'd like to have in the system, and then build the RFP around that to ensure that they can get the most built into a system that's already available in a market from a standard system instead of customizing the products. He also recommended using consultants liberally and frequently. And two areas that he mentioned there were going through to use them for negotiations to help slim down the initial cost, but also focusing on the total lifetime costs. And he said that that could be done by establishing well-defined multi-year maintenance support contracts and keeping the fee escalations in mind when that happens, so that can help keep the long-term costs down. And also those consultants have a lot of good experience dealing with vendors and knowing how to, what questions to ask, and that can help to minimize conflicts and can help be your advocate when there are conflicts or differences of opinion between the buyer and the sellers. The other thing was during technology transition operations, transitioning those new technologies or operations into place, using consultants for planning, design, and the implementation, and that includes specifically for the cutover. Key cutover considerations were preparing early to make sure that any of the equipment that might stay in place is able to plug in to the new equipment that comes in, and so that they can communicate and that they're using the same protocols. He gave an example of what they've done for their cutover, and typically they will cut over to a new system that's running in parallel. They'll have it on for 2 hours, record the data as it's operating, fall back to the old system, and then take a short period of time to assess the performance, look at the data, make any fixes, and then do that process 3 times until they finally leave the system up and running. The new system up and running, but they will leave the old system there and available for 3 months just in case, worst case scenario, they need to cut back. In terms of staffing and training, he said this is an important area to help shorten timelines for procurement that's limited by time availability. And one way to do that is to hire staff that are specifically, or hire staff to backfill your regular full-time staff, so that those full-time staff can be dedicated to the procurement process, so that they're not trying to do 2 jobs at once. And that to him was very important because it helps shorten the time frame, as I mentioned, but also builds in user buy-in from those staff that are helping with the procurement process, because they're involved and familiar with the technologies that are being designed and implemented.
Sorry, Rob, you have 1 more minute.
Okay, thank you. And the other thing that he mentioned under the staffing and training is to build out the OTS, operator training simulator, in parallel, so that that can be ready to go once the system is ready, and then also to engage all the operators in user acceptance testing for familiarity even before the training starts, so that they are bought into the equipment that's coming and know how to use it. Last, he mentioned the technologies that are on the horizon, and I don't think this is any surprise to you, but wind and solar, and he mentioned specifically coupled resources with batteries as well. And he sees more and more the buildup of the use of distributed generation resources, but his real highlight was on the coming wave of visibility and controllability of those distributed generation resources on the grid, and that overcoming some of the challenges that exist now with having difficulty modeling those resources that are on the grid, but the grid operators don't have that visibility into the generation resources and how they're operating. And he sees that as something that's changing, and that new technologies will come into force to be able to manage those. So those were the highlights of the things that that Darren mentioned to me. It was a great interview, and I was real happy to have that. So hopefully you all got something from that, and I'll be happy to answer any questions during the Q&A session on what we discussed.
Okay, thank you very much, Rob, for giving us such informative and interesting presentation. For your information, currently we have about 300 participants through Zoom platform and almost 250 from live streaming YouTube. It means there are almost 550 audience of this webinar. Sekali lagi untuk semua peserta, kami mengingatkan untuk mengisi absensi, feedback, dan pertanyaan melalui link yang sudah di-share di chatroom. Untuk pertanyaan bisa juga langsung ditanyakan di chatroom. Jangan lupa ditulis nama dan unit penanya serta nama tujuan speakernya. Terima kasih. So, the third speaker will be the team from KAISO, our sister company in the US. The team led by Mr. Hani Halarian. He is the Executive Director, Power System Technology Operation at KAISO. He is accompanied by Mr. Roberto Bayetti. He is Director, Security, Architecture, QA, and Model Management at KAISO. With him as well, Pak Dede Subakti. He is Director of Operation, Engineering Service at KAISO. He was born in Jakarta, asli dari Grogol ya Pak, and has several time technical visits to PLN before the pandemic. So, Mr. Hani and teams, you have 20 minutes to deliver your presentation. Now, the floor is yours.
Didi. Yeah, thank you very much. Selamat siang. So I will start the presentations really quick, and then I will pass this to Roberto and Hani. I will share a little bit from the business perspective and from the need itself. So California ISO has traditionally been the grid operators in California, but as our business needs growing, we become more and more responsible for a larger footprint. So at this point in time, as of today, we are responsible for reliability coordinations for about 80% of the Western interconnection. And what we call the Western interconnections is the area from the West Coast, and it actually cover about 14 states in the western part of the United States. The Western interconnection is about 1.8 million square miles. I guess that's about 4.6 million square kilometers. So if you imagine 4.6 million square kilometers, and then 80% of that is part of the reliability coordinations within California ISO. So as our services grows, we have the need to expand our EMS and our network application, as well as our EMS network application, and including our market optimization engine and whatnot. So this graph is going to try to illustrate on how the network model, or our EMS, the number of substation, the number of display, have been growing ever since 2011, 2017, and we don't actually have a chart now all the way to 2020 and 2021, but it's been growing quite a bit. And because of the growth, we have the need, similar to PLN, where we have a need to actually have to expand our capability that have the ability to include situational awareness and include some type of a contingency analysis. And the spec that I gave to Hani and others was to be able to calculate contingency analysis about 10,000 scenarios and evaluate it every 5 minutes. So that was the original part of the original requirement that we have. Another portions to keep in mind is to make sure that the operator, the system operator in California ISO, have a need for situational awareness. And when we talked about situational awareness, we talked about the fact that not just the EMS portion that is right here, where we have one-line display, where we have alarm, and we have SCADA, but also have a geospatial need, such as earthquake, because California is very prone to earthquake, such as fire season. We have a lot of forest fire. So we have to have that situational awareness for that. Similar to many other system operator, we have security analysis that Mr. Suroso was talking about, real-time contingency analysis, including items such as remedial action scheme, or often in Indonesia, we call it the defense scheme. So many of these applications are part of the situational awareness that was put in place as part of the requirement as we build a new or upgraded EMS, which we are right now in the Siemens Spectrum 7. So with that, I'm going to pass this really quick to Roberto, who's going to talk about the system architecture itself.
Thank you, and good evening, everyone. Good morning for the ones at the other side of the globe. I'd like to go a little bit of a structure of what the architecture we decided to have. And one of the things that you will notice is that we have a central bus where we communicate basically everything between every application that we have with any other application. So this is was a decision from the beginning of having a system like that, and we incorporate systems that are from the EMS vendor and from other vendors that are not necessarily EMS, and also for homegrown applications. So the exchange information is all there. In there, you can see applications that are related to data specifically from the contractual aspects, like ETCC or contractual requirements and characteristics of the system, like a master file. Then we go to the outage systems, transaction schedule, forecasting, voltage and dynamic security assessment, and ADS, which is where we send the signals to the market participants and generation. Then the three applications on the side are related to the market system, where OSIS is basically our input of the data, and CMRIs are reporting tools. And then on the bottom part, we have the SCADA AGC UI, which is, we consider that one component, with an associated historian, which is PI. And then the applications, which are basically the core of everything else that happens afterward, which is EMNA. We call it EMNA network apps, which is basically contingency analysis and state estimator. From there, we feed data into the other parts of the systems, and even for the EIM participants, we offer services to have them also having the capability to have RTCA and calculated their systems. And we have also this DAL, which is the data access layer, which is allow basically collect information from every one of every system and be able to show it to the operator. And the rest of the bottom part are specifically related to the market and the real-time market, the forward market, price corrections, etc., including also some applications related to data input for market participant and EIM participants. So there is one more that I'd like to mention, which is the EMMS, which is in the top left of the system. That system is the one that is basically going to provide the data, the network model for all applications on this particular schema. And let's go to the next slide, and I will describe a little bit more, because we consider that basically a key element of our system. This enterprise model manager is exactly that, is what we have to be able to model everything that we have for the entire enterprise. If you see, we have data from external utilities, GIS, and market commercial data using SIM and some other forms of file and data exchanges. Basically, SIM is our standard inside the tool, and we use SIM 15 for that. But it has a specific characteristic, which is a time-based modeling. As you know, that we have markets that have a day ahead. So this tool basically is able to deliver the model for the day ahead, and the next day is able to do for the real-time market. It's all automated. And it has also things for the future, where you define, this is what I'm going to have in my model in the future, not now, but I'm modeling right now. So it has a very interesting tool, which is automatic one-line builder, allow specifically for the number of substations and displays that we have is a very important tool to have. We also keep obviously auditing and history about what's happening, and we also import GIS. And this feeds all EMS, all advanced UI, all DNA, markets, VSA, outage management system. Every system it gets data from the model from the IMM. Go to the next one, Didi, please. And you see in here the enterprise EMS is basically in the center for our system, and it also provided exchange data with all other applications, OMS, DNA, and it has what we call advanced user interface and data access layer. Data access layer in general is where we have get all the data from everywhere and make it available so we can use it in the advanced user interface and combine the data and be able to present it in a more intelligent way. A graph that shows you what has happened, what is happening currently, and what will happen using information from multiple applications in different things. That includes the market and includes a real-time market. But we also have information, as was mentioned, about fire, earthquake, water, etc. So it's a very interesting system, a concept that we like from the point of view of the architecture. So this is the end of my presentation. I think I will be now switching to Mr. Hani.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. We were trying to figure out what do we want to present, and actually this is the enterprise and already covered by Roberto, which is data access layer and advanced user interface. The important part that you need to understand about data access layer is in the past and until this concept existed, if you need anything on a display in the EMS, you'd have to bring that whole data, SCADA, and model it in the EMS. It have to be a part of your SCADA. With data access layer, I can bring information from any other application, whether it's the market, OMS, any other application, and put it in the EMS without bringing it to the SCADA. And that gives it a little bit power, because now I keep the EMS pure, but I can bring a lot of other information, put it on the EMS display, and it looks like it's part of the EMS, but I only brought the data that I care about and not have to model everything in the EMS. That's the power of that. And once you have that one, it gives you an advanced alarm and advanced capability, because I can now mix and match data from different application. I can look at voltage stability from another application, or dynamic stability, or the market for tomorrow, and see if the flow changed more than X number percentage or megawatt. I can generate an alarm. The alarm would go to the EMS, and it'll generate and shows to the operator as if it actually came from the EMS. So that's the power of advanced user interface and data access. Next slide. I wanted to cover the, go ahead to the next slide. You can just, I wanted to give you a little bit of an idea of our plan, because I know you're thinking about a new EMS. We actually wrote all our requirement in 2014. We spent 2015 in the RFP. And in 2016, are you okay? Yeah. In 2016, we actually started the project, and you can see the green, it was the baseline and what we plan on doing. And somewhere along the way, a lot of things have changed. You can click a few more, Didi. And what happened is we start getting a change in our requirement. When we spec the system, we only have 2,000 substations, 2,000 displays, size the system for 4,000, twice of what we have. But along the way, we became an EIM. We picked up Pacific Corp and other entities, so we have to expand our model. And somewhere in 2018, there was an announcement that we're going to become the RC, which is the Reliability Coordinator of the West, which we pick up everybody in the whole West. So really that changed our plan. And I'm giving you a little bit, at least the planning phase, design phase, construction, but definitely FAT and SAT end up growing a lot more. We have a scope change. We have to build a white data sharing pool for the West. And so that changed the process for us. But it's important to give it justice. I think when it comes to FAT, SAT, we never really had enough time. So I would say upfront, make sure that you plan it. The other benefit that I noticed, we actually did FAT, SAT, and parallel operation. We wanted that for 6 months. What we were learning after we start going is sometimes it is better to overlap those than to wait till FAT 100% complete before you start SAT, and SAT 100% complete before you start parallel operation. Parallel operation is 100% complete before you start actually building and not go live, but having the system ready. So that these kind of things actually becomes very beneficial. Also, you have a multiple system. The other part I was going to mention is how did we actually end up transferring the system. We actually have a different vendor for our old EMS. We have a new vendor. Luckily, we have a dual channel, dual ported RTU, and we were able to actually put one RTU on the old EMS, another one on the new EMS, and we have separate channels. What we did with all the points, we put them on an ICCP node, 3 ICCP node, and connected the old and the new EMS. So all the data actually have redundancy going to both systems, and that gives you a lot of capability to check your data and have a system running in parallel all the time, and you can actually verify and do point-to-point checkout. So there's a lot of beneficial values in that. Next slide. I just want to mention about display build, because we mentioned that we started with 2,000 station, 2,000 display, and somewhere along the way, we knew we were going to have to build them. We didn't want to take the display and convert them. We felt that was not a good idea. And I'm glad we didn't, because somewhere along the way, we have to go from 2,000 displays. I think right now we built 13,000 display. And when you build that many, you have to think 10,000 displays. If you take 25 minutes or half an hour, that's 5,000 hours worth of build displays. And in the lifespan of an EMS, the model change for us, it changes every month, which means my display, at least a good chunk of those displays need to be updated every month. So that's a lot of display build and update. And so we wanted something to actually make it efficient. The 25 minutes is average. Obviously, if it's a simple display, it gets generated in a minute. Complicated might take an hour or so. Next slide. The last subject I want to touch on, and I'm going to respect, I got 3 minutes, is active-active. We always have master reserve. We were not really, we always heard the active-active concept. What was interesting about it, it's very powerful, and it takes a little bit of a mind and paradigm shift in how you think, because when you have active-active, you really have a complete EMS, both of them up and running. You just decide which one is the system of record and which one is the not system of record. And that means the switch happens in seconds. There is no failover. It's really, you just decide who's in charge. And that is very powerful in a switch, but it's also very powerful in debugging, in patching. You have 100% availability. You don't have planned outages. One other features that we felt was very powerful, and a lot of the stuff we learned as we did parallel production and go live, is the ability to have the best of both sides. And that is a powerful thing, because I can tell the system of record you're in charge, but if an RTU fails on you, I want you to jump to the other system of record and find if they have a better data and go get that data. So at any moment in time, my system of record on one side will have the best data from either side, whether it's an RTU or a point or telemetry, whatever it is. And that means I'm always having, at least as long as one of my two systems is scanning RTUs, as long as one of them is working, and I have dual ported RTUs, then I actually have a very solid, accurate system. And that's where the power comes in. And I think that's pretty much my last. Yeah. Thank you.
Okay, thank you very much, Mr. Hani and team from KAISO for giving us such fruitful and interesting presentation. Sekali lagi untuk semua peserta, kami mengingatkan untuk mengisi absensi, feedback, dan pertanyaan melalui link yang sudah di-share di chat room. Untuk pertanyaan bisa juga langsung ditanyakan di chat room tersebut, tetapi jangan lupa dituliskan nama dan unit penanya serta nama tujuan speakernya. Terima kasih. So the fourth speaker will be the team from DIBAR. The team consists of Mr. Oscar De Lima and Francisco De Lima. Both are director of DIBAR. They have experiences as consultant for international organizations like IDB, ADB, and UNDP. But since the significant time difference, currently after midnight in Caracas, Venezuela, we have to reply their recorded video presentation. But anyway, they still try to join this webinar through live YouTube. So here's the video presentation of DIBAR.
Hi everyone, today we have the honor of presenting to you the consultant challenges for variable renewable energy integration in control centers. Who we are, real quick, we are a couple of power systems engineers, along with some other engineers and consultants, assistant consultants that help us in this task. We've been doing control centers only for the past 35 years. In our experience, we accrue 55 projects mostly in Latin America, South America, Central America, and some projects in Jordan, Iraq, and a couple of projects in US. We have offices in Sweden and Venezuela. Just to show you how the renewable energy are drivers for modernization, I have 4 examples here that are located, all of them in Latin America, all of which required an AGC implementation study and later a full-blown AGC. Real quickly, these were in Chile, where there was an operate project, a preliminary project, and then an operate project. In Camesa, Argentina, also an AGC implementation study, and the specifications for the replacement were required to support these plant expansions in renewable energy. And in Uruguay, who started first on this renewable implementation and integration, did it back in 2015. Now we're going to visit the facts to consider because of renewables and their relationship to control centers. Well, we all know that power systems are undergoing significant changes, and these changes are driven by renewable, variable energy, and distributed energy sources. We all know that integration of renewables creates challenges that are increasing over time as the penetration of these energies raises. One clear and very well understood problem with the renewable energies is it cannot be accurately predicted, so the corrective actions in the generation dispatch need to happen more often and basically on a second-by-second basis, and this can only be achieved by an automatic generation control program. Another fact to keep in mind is that not all countries are in the same stage of renewables integration. Just to give you an example, PLN in Indonesia is right now at around 6% integration, and they plan to move to 23% by 2025. Consultants designing control centers for renewable energy must have a clear and deep knowledge and understanding of the current conditions of the existing control center. And the reason for this is because many control centers out there are at end-of-life condition. They have been working for over 10 years. Hardware is obsolete and unsupported, and maybe the support from the original vendor is not available anymore or is too costly to keep. So this condition must be acknowledged by the consultant because of the times involved in the project execution. One thing about renewables also is that these are expanded basically in 2 areas: as power central in a centralized facility or distributed in residential level. Most countries under development are expanding on a centralized manner, and since smart grids and residential level generation of renewables is still limited because there is lack of financing and energy costs. An important thing to consider also for the consultant is that the operations are based on several factors. When you operate with renewables, you have to consider the system size you're operating, where are these sources relative to the load centers, what is the demand characteristics. So the design must consider them all. Renewables are distributed across large distances, therefore the consultant must acknowledge that it is required to have SCADA system to supervise and to control those new facilities. Also, the consultant must clearly understand the regulatory framework under which the SCADA and the EMS and the control center will operate, and that means understanding the actual and the future if there are changes in vision. This is mandatory because the type of applications that will be required and safely support the power operations will be highly dependent on the framework and the regulatory mandate. Another point to consider is the database and the online overview displays. We are considering these as a very valuable assets that need to be capitalized, but not in the whole. In other words, I don't mean moving the database and online displays as they are, but just select what is really important and required to be able to use the new enhanced features that are available from world-class vendors. Trying to port the one-line diagrams and the database as is would probably compromise the use of advanced features. Also, you must acknowledge and consider that operators and generator schedules need to undergo into a well-designed training plan, and that is because they need to increase their in-house technical strengths before, during, and after the new control center is in service. The consultant's design must be able to increase the flexibility of the power system to incorporate large volumes of renewable energies, because you must recognize that the service must continue even under large variations of the supply or the demand. And here we have 5 steps or 5 different phases we have identified as far as the renewable integration. Phase number 1 is where the impact of renewable is not foreseen, and that it means using the control center would be enough. That is because of the volumes of renewables are low. Then there is a phase where there is need for flexibility and a well-designed control center to support the penetration during the first stages of this integration plan. The third phase is, as renewables increase, we need to safely handle large volumes of renewable energy, and this will require investment in network equipment like battery storage systems, FACTS, STATCOMs, and several other equipment that need to be monitored and operated from the control room. As a fourth phase, as larger volumes are incorporated, then we might find seasonal surpluses, and this seasonal surplus will require the management of curtailments. Curtail management is something that is going to show up in what we call phase 4 of the renewables development, and also the need for intra-hour imbalances. Compensation will be required, and for this you will need to have the capability of doing short-term regeneration rescheduling. That means within the hour. And finally, there will be a time, and stage 4 and stage 5 are going parallel, I would say. There should be an early identification when the renewables control centers needs to be separated and a control center of its own needs to be created to assure the operation is under secure condition and to maximize the volumes of energy delivered to the grid. Continuing with the renewables facts to consider, it is important to recognize that the operator will eventually find situations where the changes in generations will not be evident, and this requires to have enhanced situational awareness tools to early identify risky patterns that could be happening in the system without the full knowledge or acknowledgement from the operators. Also, improved alarming and use of composite objects to supervise renewable energy facilities must be specified. In addition, they must consider that maybe some distribution lines on the part of the distribution network will be necessary to be monitored to safely evacuate some of the renewables that are installed and interconnected to the system at these voltage levels. Obviously, if there is more need for SCADA and communications to the renewables facilities, also there is more need for enhanced or additional communication infrastructure. In addition to that, if the consultant specifies standards protocols, this will contribute to reduce the total cost of ownership of the control center. An important fact are the historian systems. These should now come with data mining and pattern recognition software. These will improve the operations and will improve also the after-the-fact analysis. Another important thing to consider is that the hourly schedule might be reduced from 1 hour to 15-minute intervals or even shorter, and this will require in the control room tools to actually do this rescheduling properly. These tools should interface directly with the AGC in order to give prompt responses that the operator needs. It is also very crucial that from the point of view of the operational plan, the generation mix assures that there is always enough inertia and fault power to support the system's reliability. The network islanding conditions must be carefully assessed, and the reason for this is that because upon restoration, the multi-island AGC capabilities should be planned, especially when there are renewables that could be in one of the islands that are on the restoration process. Now let's go quickly on what are the major functions the operator will need under this renewable energy environment. First, the AGC should be able to manage generation curtailment, and that is basically located, will be needed by phase 4 when you have surplus energy at some time, so you cannot evacuate safely the generation. The ramp monitoring is mandatory. Nowadays, in the past, it was enough to monitor the high raise and lower secondary reserve. Now it's mandatory to monitor the ramp to assure that you have, in the times the changes are happening in the generation, you can respond quickly without deterioration of the AGC response. Also, dispatching the battery storage system is important. Therefore, there should be monitoring and controls of its operation, fully control of its operation. Monitoring the state of charge of the battery storage system is one of the things that the AGC must have. In addition to that, there are some additional functions that have been added to control centers, some of which are added to the generation control, and those are intended to do a closed-loop control to voltage controls at scheduled interconnection points or power factor control at specific locations in the grid. Another set of tools that should be available for the operators of the renewables within the control room environments are the forecasting tools. These forecasting tools should be coupled with the in-room rescheduling tools that will help the operator do a very short-term unit commitment based on existing plans and based on current condition or forecasts. So this is something that the consultant of the control center must keep in mind and make sure that they have tools to not only forecast but also correlate the conditions in the forecasted conditions with the productions. Another important tool that must be specified are the historic analytics. These tools run on the top of the historians and provide extended capabilities in historical analysis, such as data mining, pattern recognition. They are asset-oriented to reduce cost and supervise equipment operation. They use machine learning-based applications to improve the recognition and the other tasks. Also, they should have graphical tools to do comparisons and analysis in an easy and fast way, and of course have predictive analytics. All of these add-ons, I would say, to a standard historian must be considered if you plan on a control center that will perform under large integrations of renewables. Now let's talk about the operator training, which plays a key role on the renewable energy operations. This new dispatcher training simulator must have enhanced capabilities to simulate the renewable generation. On the other side, it must consider that some of the rescheduling tools should be integrated into the OTS. Why? Because operator will have to make fast decisions upon changes in the renewables, and that will require that those tools are also integrated into the OTS environment. Enhanced frequency models to account for system inertial impact in the simulation will be necessary because of the inertia issues related to the renewables, and of course must consider the load forecasting resources and tools that are used so that the operator can have a full training on all the renewable aspects and the operation of the safely operation of the system. Finally, if the project considers the redesign of the control room, it is very important that these new control rooms use of extended and enhance visualization video walls. Also, the console's layout is carefully reviewed and designed. Consoles are ergonomic as much as possible so the operators feel comfortable during the work sessions. And the building itself should be designed keeping in mind that it is a mission-critical facility in terms of security, power supply, water supply, and everything that goes with it. Also, since we're talking about renewable energies, the green building concept should always be embedded into the architectural and engineering design of the building. Now let's review some of the challenges that the consultant has to lead with. One is the convergence between OT and IT and the security implications that this has to keep the control center isolated without compromising possibilities of integrating OT and IT. The other thing is the Internet of Things. It is around, it is a fact, and must be and can be properly used within the control room applications to enhance monitoring of devices. Also, we must make sure that the latest technology is identified, used, but being always sure that the technology is safe. It is important that the procurement leaders enable innovation, agility, and supply certainty. And this is important because sometimes this becomes a problem. Okay, we find that the leaders of the control centers are not keen to innovation. It is also important to keep in mind the security standards compliance, and which affects budgets and also the workloads. There should be telecommunication strategies and methodologies in place and followed. And also, the organizational responsibilities for the control centers must be clearly established, especially if you have a multi-site supervision facility. Okay, now I will basically rush into the success steps because of time constraints, but basically we need to review the corporate vision, define the teams that will be in charge of the project migration, ensuring that we have a top management commitment and that there is enough funding to succeed and complete the project. There is a need to prepare a business case. There is a need to also define project requirements that are in line with the company's strategic vision and also that follow international studies, standards, and regulatory commitments. It is very, very important not to say that choosing the right consultant is one of the keys of success, because he will help the company build a complete specification, and also he will aid in focusing in the marketing system key vendors. This is important not to leave aside, because in our industry there are many stories and many problems related to vendors that come in and come out of the business. Then you have to prepare a control center request for proposal, and that is based on the specifications. Then, of course, there has to be the selection, and here the consultant comes in as a good assistance to the company to select the right system based on legal, cost, and technical specification compliance. And finally, make sure that you have a very good statement of work. And when I mean good statement of work, meaning that you have a single document and you don't leave for the rest of the project with two documents that go in parallel and might be contradicting. So make all the effort to have the statement of work reflect exactly what the needs are for the control center. Of course, train and involve the teams in this system integration process, perform project control, and of course apply all the techniques to follow up a project adequately. Data bay and display asset capitalization needs to be reviewed and understood and know to what extent it will be recovered and recapitalized. Of course, test and prepare for cutover, and then very last, and I would say the most important, keep improving, meaning that once the system is already working, there's always room for improving, and this never ends. And when you feel it's coming to an end, it's because you have to replace the system again. I just want to say to you all, Terima kasih. Thank you very much. Muchas gracias.
Thank you very much, Oscar and Francisco, for giving us such informative and interesting presentation. Sekali lagi untuk semua peserta, kami mengingatkan untuk mengisi absensi, feedback, dan pertanyaan melalui link yang sudah di-share di chat room. Untuk pertanyaan bisa juga langsung ditanyakan di chat room. Jangan lupa dituliskan nama dan unit penanya serta nama tujuan speakernya. Sebagai informasi, webinar ini baru seri pertama dari rencana 10 seri yang kita rencanakan. Feedback dari para peserta akan sangat membantu panitia untuk mendapatkan bentuk dan topik knowledge sharing yang paling optimal untuk peningkatan kemampuan para power system engineer di PLN. Okay, the last groups of speakers will be the team from EPRI and NREL. The team consists of Adrian Kelly, Senior Technical Leader in EPRI, Mr. Hongming Zheng, as Chief Modeling Engineer in NREL, Mr. Seung Choi, Lead Engineer in NREL. So, Mr. Adrian and team, you have 40 minutes to deliver your presentations. Now, the floor is yours.
Yeah, thank you. Thank you very much. Thank you, hearers. Yeah, I asked my colleague to run the slides so we can use less time to finish this presentation. First of all, thank you. There's an echo. Thank you for having us for this big meeting. Really exciting to see all those introduction about your system and also the different perspective about the control center design. So the first we want to share overview. As you guys know, so Unreal is a research in the lab in the US. In the last decades, we are focused on the renewable energy and study. And lately, we integrate RC level, coordinator level, control center into the Unreal, so that we can leverage the renewable research, technology into the control room to stay support the industry and future development. So from our perspective, we think, the overall the control room, if we talk about in a complete control room, contain the 5 in the sector, and start from the number 1, the SCADA and EMS, and go to the historian. This is bundled very closely, and then go to the stability assessment, and then the PMU. This is a wide area monitoring system. So eventually market system. So that's kind of the 5 sector that can be the separate vendor, and some could be same vendor, but overall those have a very close integration connection. Next one. So click song, please. Yeah, basically we want to start first, and as we heard from Robert, the ERCOT folks shared, they want to say the one trick they make a success is make your system simple. And that simple is means more robust in general. That's the reason. So when we look at your project plan, less than 2 years and get it up running with a new system, and also looking at your system, in the near term, 25% renewable penetration, we think that the current technology could be fit in very well, as you already heard. So ERCOT someday around 60% high wind and penetration, and our CAISO already around 75% for those current kind of the springtime. So those tell the technology is very adequacy at this point. The key is how to implement in the limited time, how to minimize the cost. That's we think that the first make sure focus on your key the application components, which start from the front end measurement, RTU, then go to SCADA, alarm, then estimation, condition analysis, and automatic control, and economic dispatch. Then also include a study function. Those is a fundamental piece. Most vendor, have the product fit in. That's kind of the foundation. Make sure live with the space product, and as much as possible in the first phase. Then go to the next one. Click next one, please. Then you can extend your EMS and SCADA to cover more functionality. For example, you can extend with fast topology process. You can get a quick topology results and alarm and tell you how the system changed before you get the state machine or RTCA and tell you what's the real-time violation. Then you can have those outage detection, and it can tell you is really the planned outage or the forced outage. Those will help operator to get situation awareness more effectively. And at the bottom, you can see dynamic rating. If you want to leverage your weather temperature to increase your transmission capacity utilization, those can help. And then the scientific analysis, like the line outage distribution and network scientific analysis, those is a kind of backup your RTCA, because they never run into the convergence issue. They're always solving with scientificity. That can give you a backup. Then some application like look overhead, look at study, because renewable has more uncertainty. If we have a look ahead study RTCA, you can get a better view. So those is a kind of a fundamental EMS core, the core function plus extension. Got this done in the 2 years. I think it's manageable. Even it's challenging, but it's manageable. Next one. After we get to finish those EMS SCADA and keep running, then the next step. In the meantime, so you get your the historian, and this historian not just the data storage, also the data using for the ad hoc analysis, visualization, and we see the beautiful the layer in the CAISO system, integrated weather and all those information. So a lot of the data interface can line up with the historic system, because that system can import not just the EMS information, can import the weather and all those data layer. So that's kind of the when we plan those computer center, make sure you have very strong and good foundation for storing and data management. That's including visualization and the data analytics capability. Next one. So after, this is in place and keep running, so assuming you have a good estimation solution, good RTCS solution, you are ready to integrate your grid stability and assessment tool. This can be included with multi-stability, transient stability, and small signal stability. All can be real time. So the key part is not the software. The key part is modeling. Without a good modeling, including your network model and also your we call it RAS, you call it defense scheme. Without those models in good shape, your solution not trustable. The operator may not have confidence to use. That's the reason. So really, get a estimation and RTCA running good quality. Then in the meantime, have those the stability model, testing, validate. Then in a very short time window, could be 6 months, you can get all those integrated and running for the operation use based on the industry experience in the US. Next one. So again, when we talk about history, we want to make sure that the history not just support EMS, can support the your other tool like the stability tool and even the PMU tool. So when we talk about a wide area monitoring system, which is new, right? Everybody exciting about the PMU and the high resolution signal. The bigger challenge is how to get that, for the operation use. So in that case, when start this effort, make sure you have a very clear, assessment. What's the user case, and what's the kind of the benefits you can achieve for the operation level, and is any standard from your regulation authority, you need to meet that requirement. For example, the inertia. Do you need to estimate the inertia in the real time? And the PMU could fit that role very well. And also PMU is a really good one for the islanding detection and also the system restoration. So those is we will have a more detailed discussion in the future, but that's just say, when you have this PMU project kick off, you need to have the very clear and user case and the order you can put online in the several years. This is not as quick as EMS, to be honest, because the EMS, the model-based solution, this is a measurement-based solution, take more time to validate the results. Next one. Assuming all those kind of stability and the reliability, even resilience focused on the application ready and running well, and the next step is could be get a more the market function in place. This is foundation is you have to have enough generation resource. Capacity is tons of capacity, and also the transmission capacity also is adequacy. With these two conditions, you are ready to move on those market. So that's kind of data you can get from estimation, you can get a condition analysis, you can get it from stability analysis. So those three data flow can build up upon those constraints for the market to use. So those are the on the right side, I don't need to go to detail, and basically that's a key market components. So to get there, so really is you have the EMS security and the historing all in good place, and also you have the motivation for the operation economics. So those is the bigger picture we think that for the whole control center implementation and a 5-step, but as a good coordination kick in, you can implement in good order. Next one. So here's a little bit more description that go to next step. So this is a way, kind of the more, working on at Unreal and in collab with the partner. So how we can, incorporate those renewable elements into the EMS, and that not just EMS, could be EMS as well. So basically those on the left side, this field measurement, the field equipment, get into the right side, you can see that those greatest and service. In the future, it's not just the traditional units. It can be, even the inverter-based units can be, grid service provider. Those is a lot of information and a lot of data, and how to manage that. That's kind of the ongoing effort. And also because this renewable is not like the traditional units. It's a very schedule is certain. So there's a lot of the uncertainty. So that's the kind of probability analytics and uncertainty model will be kicked in. Those is a time consuming and calculation. How that kind of the integrated with the EMS and DMS. We think that that's a lot of good research could be help out. And to get those future system, the EMS, DMS, the information exchange will be much more than right now. Right now it's separate, but in the future could be more integrated, and also in the warm system as well. So to get there really manages a much large scale the data set and a much quicker change. We need automation, we need intelligence, and also resilience, and to help the system, operate in the preventive mode. So those is the kind of the effort we are trying to leverage the U.S. Department of Energy funding and the utility plug-in to build some paths and to verify the concept. Hopefully, some of those technology can be plugged in the PLN going forward. Next one. So this is a kind of a summarize right now. So we know we can operate the traditional grid without issue, and today it's penetration already go to the light loading could be 50% even more at the U.S. certain area, and but going forward, next 10 years, that renewable penetration even can go to the high percentage in the heavy summer load. In that case, how we manage that, I think that we live on the current situation, the modernized distribution system, but it's separated from transmission. A lot of the operation is based on raw and automated, but hardware, centric, and a centralized control, all the generation service. So those is the kind of where we are. To work out the future grid, when you look at the future setting, number one, the architecture will be more heater regions, and also the transmission distribution, the layer won't be like the current very clear cut. You have to leverage the data in between, and also we're looking for the partially the autonomous energy system. I mean, a lot of the things could be automated. And robust and intelligent software and high speed communication technology can be used to help those data exchange, decentralized grid service, and advanced cybersecurity. All those is a future pattern. I think that no matter US and Indonesia, Asian countries, utility, all facing the same. So that because of decarbonization and green energy will be coming. So really looking for this project opportunity to working with the PR team and our partner to support your project. Thank you. We are done the presentation.
Yeah, thank you, Mr. Hongming. So maybe can be continued by Mr. Adrian from EPRI.
We can do that. This is Mark McGranigan. I'll just introduce you, Adrian. Adrian Kelly is the head of our Control Center of the Future research at EPRI, and I will control the slides for Adrian as we will go through at a high level some of the important control room of the future research that we have going on. Thanks, Adrian.
Thanks, Mark. Nice to talk to you all. Hopefully we'll keep this brief. I know it's been a great discussion so far, so you can move on the slides. What we're looking for here is to think about, I guess, start with the comment at the bottom. It's important not to start with the technologies. So a lot of the things we've talked about is, can we fit technologies onto use cases? When we're talking about Control Center of the Future roadmaps, architectures, we think about use cases first. So we always start with drivers. What are the PLN future system risks? You're going to be expanding a lot of load, a lot of generation. You're going to be adding new business functions. the utility model might break. You'll have regulatory drivers that are going to change how you operate. So start with the drivers. That leads on to architecture. And what I mean by architecture is what Hong Ming presented, what Roberto presented from CAISO. So setting up your architecture is the critical stage for your new control center design. And also architecture in terms of physical architecture, your building design and layout. So what we would emphasize is not to start with AI, 5G, those types of things. Always start with your drivers and your architectures. And once you find the use cases, you'll find the technologies that are needed to be carried out. So yeah, we start with the drivers, find the risks, and then that leads on to the control center technologies. So next slide, Mark. Yeah, here's an example of a functional model that we propose. It's similar to what Hong Ming went through previously. So at the top, you've got your purposes. In a previous presentation, you mentioned reliability, safety, green energy, that type of thing. That leads into the KPIs and priorities that you might need. So being N-1 secure, keeping voltage within limits. And that leads on to your functions and processes, which are your key kind of areas. Contingency mitigation, power transmission, voltage management, and then redispatching of generation, balancing generation, monitoring voltage. So the key thing here is purposes lead to priorities, priorities lead to functions and processes. And it's at the function and processes layers that we define what the architecture and the technology that's needed for the future control center. Next slide, Mark. And once we know what your functions are, so for example, balancing generation and demand, then we can kind of map technology. So as you can see here, the tools or applications that are needed in your future control center can be mapped directly to these. So balancing generation and demand, you will need a tool to verify your capacity allocation. You will need a tool for HVDC. You will need a tool for balancing, AGC, market systems, demand forecasting, renewable energy. Now, I'm not going to go through them all, but the key thing here is functions and processes, and then they are mapped to technologies. And once you go through this exercise, which is PLN specific, this will be unique to your system, and that helps to define what your architecture is going to be and what your technology needs are going to be as you move towards the future control center. You can go 2 slides on, Mark, and these are in the deck. You can take a look. These are ones we have done before. And then when we think about the control center of the future, especially road mapping the control center of the future, we look at inputs, algorithms and outputs. So for each technology, it has an algorithm or a methodology for how it operates. It has data and model inputs, and it has outputs in terms of controls by the tool or operator decision support. So each technology that we define for the future control center should have this model, input to algorithm, algorithm to output. And everything is interconnected. So your data and IT systems link with your hardware, your buildings, and your ergonomics in your control room. And of course, this is then developed underpinned by the largest cog there, which is the human performance aspect, making sure that the human operator can interact with both the data and IT systems and the hardware building. This is just a methodology for how we would roadmap out the future control center. And it gives you some ideas on how this might be done at a strategic level. Next slide, Mark. When we're talking about technology assessment, then we always look at the technology toolbox, which is over on the left. These are some of the things Mark's going to touch on in the next few slides. So artificial intelligence, DSA, digital substation, wide area monitoring. We need a way to measure how they will progress. So artificial intelligence is considered kind of progressing now, but still not very advanced for transmission technology use cases. How do we measure that as it goes through the years? Are there KPIs? Is there vendor benchmarks we can do? We want to look at what the technology idealized end state is, and then define the trend from stage 1, which is today, to stage 5, which is the most advanced stage. Once we have the technology trend, we can kind of map where PLN are on that trend. So are you stage 1, are you stage 2? And how do we get from stage 2 to 3, 3 to 4, 4 to 5? And then it's important then to map, of course, looping that back to what we talked about, mapping those risks to the technologies. So your future system risks being new renewables, demand growth, all of that, new technology. How do they map onto the technologies for the future control center? That's a pretty rough guide on how you would roadmap future control center. So next slide, Mark, might show you Yeah, so this is kind of a talk on, what the future of control in the transmission control center is. So what we're seeing kind of now is like increasing more and more automation, like automation of pretty much all functions within the control center. So it'd be that, AGC is long established, but what we're going to see is automatics, switching sequences are going to become more prominent. Asset health data is going to be more frequently used in decision making. Sector coupling to water, gas, wind, renewables, AI, machine learning, probabilistic operations. These are just pieces of the puzzle. They're relevant for all system operators, would probably be relevant for PLN also. But the key thing is that this level of automation is going to move human operators that are used to manually controlling systems minute to minute, hour to hour, into being observers of automated systems. So people that are like pilots on flying a plane. So overseeing automation and intervening whenever automation breaks or wherever there's an emergency, or wherever the automation doesn't know how to solve the problem. So training is important here. So you need to move your operators who are used to full situational awareness and knowing exactly what's going on and being able to control every device on the system, to operators that are comfortable sitting off and observing how the system is working, and being skilled enough and advanced enough to troubleshoot on the system and intervene whenever something is not quite right. So observers of automated systems from human control is the key lesson here. Next slide. Mark. Yeah, I'll pass to Mark. That gives you like an example of how you would roadmap and then some of the trends we're seeing. Mark's going to go through some of the kind of examples of advanced research initiatives that we're working with in the transmission operations field.
Right. Thanks a lot, Adrian. That was great. And so just to build on the architecture description that Hong Ming provided, and Adrian's overview of where we're going from a roadmap point of view in developing the control center of the future, we figured we'd just wrap up with just some specific examples of research initiatives around technologies for system operations that we think will be important in the system operations of the future. So you want to keep these technologies developments in mind as you are specifying your own roadmap and next generation control system. And these are all opportunities for information sharing going forward between the GPST efforts and PLN. So we look forward to that. So as Adrian just mentioned, everything will be automated down to local controls of local systems. We heard an emphasis on customer systems and customer integration, and the automatic controls go all the way down to electric vehicle charging and energy storage systems and fax devices and HVDC systems and wind turbine controls, and we have to integrate all that at the system operator level, and that involves data and digitalization in general. So that whole strategy about gathering data and managing data associated with these automated systems becomes absolutely critical. And so that this digitalization focus is a focus around the world as a way to operate the system more efficiently. So just to summarize some of the research challenges that we see, and I reference a table from a very good reference that came out of a road mapping effort in Europe called the ETIP SNET effort that describes the digitalization challenges and research that's going on in Europe. We heard about the architecture, that it starts with the architecture, focusing on interoperability. We heard that from Cal ISO in terms of the being able to have an integrated model that serves the different applications, the data collection systems around the RTUs, the phaser measurement units, other sensors, and the communication infrastructure to support this. Then the data management system that brings together this data and makes it available to the different applications. And as some questions in the chat we're talking about the cybersecurity, the data provides another cybersecurity opportunity to be able to detect unusual conditions and events that could be associated with cybersecurity risks. So these are very important research challenges that are being addressed in the digitalization area. A few specific areas, the integration of phaser measurement units and other sensors into a wide area monitoring and control system. This has been described in a couple of the presentations already today. This is Seagray report that came out recently on the wide area monitoring and control systems and provides a very good reference. So, but this will continue to be an area of development and research as our sensors and communication infrastructure becomes more powerful and a resource for our operators. One of the key directions is to be able to, instead of using deterministic decision making, is to include an evaluation of the stochastic nature of some of our new generation resources, of the system operations, and include those characteristics and be able to make decisions based on probabilities of problems occurring and decisions. And this is, in Europe, this is a requirement for system operators to use probabilistic risk assessment, and they have a time period that's being used to implement these tools. So this is an area to watch and make sure that our new operations centers can incorporate the tools that will be able to do these probabilistic risk assessments. Along with using those probabilistic methods, one particular area that we're working on, we've implemented this capability in Hawaii, for instance, is being able to dynamically allocate and schedule the reserves that are required to maintain the reliability of the grid. And we do this based on probabilistic approaches and probabilistic forecasting, and including the variable nature of renewable resources as they become a more important part of the overall generation mix. So dynamic reserve scheduling and allocation is an important tool that we'll be talking about in the future, I'm sure. And that that can also take advantage of artificial intelligence methods like artificial neural networks. We heard about this from in the Cal ISO presentation very clearly, the importance of what they call an integrated model management. We use the term network model management. We have a large research project working with many system operators around the world to take advantage of the common information model and build a network model management system that can interface with different applications and SCADA and EMS and the analysis applications that provide support to those tools. So this will be in a very important area for the PLN control system in the future. Looking a little bit further ahead, the concepts of digital twins, which is a concept of having a model that is running in parallel to the real system. And these concepts are being applied everywhere. And the power system is no exception. National Grid in the UK is working on a digital twin concept for their entire grid that will run in real time in parallel to their actual system and their EMS, and be able to explore contingencies and it has cybersecurity applications as well as applications for optimization and reliability. So these digital twin concepts, I think, will be very important, and figuring out how they plug into the overall operational tools that you'll be implementing is very important. And just in general, the application of artificial intelligence is one that is going to be more and more important. These tools are becoming relatively standard. And the important point, I think, for today is that the artificial intelligence applications depend on data. And so looking at you might not know right now what application, what usefulness there will be for the data that you're collecting from phaser measurement units and the energy management system and other sensors around the system, all the way down to customers. But when we put that data together in terms of potential artificial intelligence applications, it can have important benefits. So kind of working from use cases to data requirements to the values associated with artificial intelligence applications is a continuous research area that we look forward to coordinating on. Kind of alongside artificial intelligence are concepts around augmented reality and being able to use models in parallel to the real system. Right now, this is primarily focused in the area of training. So being able to take advantage of models and augmented reality approaches that don't depend on being actually connected to the system in real time can be very effective in training operators and letting them see what the actual conditions look like, but not actually controlling the system. In the future, maybe some of these tools will be implemented in actual controls, but I think that's a little bit further off. And there's some very good open source tools that are headed in this direction. So we referenced this project that RTE had as a research project in Europe. They developed a tool set called Operator Fabric that's now been pushed into the open source domain and being developed through an effort in LF Energy, open source consortium. So augmented reality is another very exciting area. So I'll just finish up by going back to the control room concepts itself. And
I can jump in there.
Yeah, go ahead, Adrian.
Yeah, on this one, we're involved now with a control, with a utility where we're thinking about a new design, a fresh design for their control center, and really, what we have to think about here is kind of levels of visualization. The middle point here being, more screens and a larger video wall does not necessarily mean situational awareness is improved. When you're thinking about designing this, be cognizant of the information that the operator needs to do their job, rather than just putting lots and lots of information in front of them. So this goes back to the slide I had on functional analysis, task analysis. So in the slide, when you looked at the CAISO control center, it's very obvious that the people at the desks, they have specific roles, and the information in front of them is key information for their roles to be carried out. So when you're building your control center and you're thinking about your visualization design, think about the roles and the tasks that the operators have to do. Think about the KPIs, what they should monitor, what are the dashboards that are needed, put them in front of them, and then think about like levels or sizes of display. So level 1 being video wall, large display. Level 2 might be a smaller overhead display might be a dashboard level. And then level 3 are the monitors on the desk, which are used for processes, monitoring and control. And all are interlinked, all are interchangeable. So in terms of like future trends, what we're seeing here is this trend towards these personal video walls, controllable for the operator, rather than static video walls that stay in place and the information doesn't change. Make them functional, flexible, and personal. So 8K, 16K displays where they're supported by applications. That's not always the case, but get as much definition into the screens as possible to make the graphical elements as viewable as possible. Consistent visual styling. So when Hongming showed and Roberto showed like these brilliant architectural designs, there's a lot of applications on there. They should all look and feel in a similar way. So your RTCA should be similar to your MMS system, for example, or your SCADA system or your DSA. You shouldn't have to be changing your mental model for how an application works. They should be kind of consistent across. Red means one thing in all applications, green means the same thing in all applications. So keep the styling of your application consistent. single user interfaces to control both the EMS or the SCADA, the operational environment, and the corporate environment. So being able to use a single keyboard mouse to interact with both environments rather than having to flick between different keyboards and mice. This is a trend we're seeing in other industries. And then single telecoms interfaces rather than having multiple phones, just have one interface, touchpad that's available to be operated from one place. So yeah, just to summarize, yeah, more screens, bigger video walls, not necessarily mean better visualization. Figure out what information they need and put that in front of the operators to help them to do their job. And then always building in your room design, it shouldn't start separate to your architecture design. It should be interlinked. What are the key information and what's the layout that's linked to your underlying enterprise architecture and the role and functions that your human operators carry out. Back to you, Mark.
That's great. And so we're just going to finish up with one reference to the ongoing pandemic and its impact on our control centers. This has been an area that EPRI has coordinated webcasts with system operators around the world from the very beginning of the pandemic in terms of how it has impacted their control center operations from all aspects, from being able to operate remotely to workforce management, but also from a disinfection point of view and monitoring the health of employees in the control center. All of those have become critical, and I think they will continue to be critical. So it is something to consider in your control room design and what types of disinfection technologies. You know, essentially your control center may start to look like a hospital room in terms of the disinfection technology. So we have a number of research efforts going on in this space around technologies and tools for disinfection, monitoring employee health and temperature during operations, and these are kind of physical things that you'll want to think about in your control center, the future design as well. And I hate to end the presentation on a down note talking about the pandemic, but it's been a great discussion. So I'll just leave it there as we head into the question and answer. Thank you very much.
Okay, thank you very much, team from NREL and EPRI, for giving us such fruitful and interesting presentations. So we have complete insight from several perspectives about control center upgrade, which are from internal PLN, international system operator, represented by KAISO, and also from designing by consultant, represented by DIBAR, and also perspective from research that represented by NREL and EPRI. Okay, now we come to the question and answer session, Q&A session. But since the time limitations, we only have 20 minutes for this session. Actually, ladies and gentlemen, we have received plenty of questions. They are very interesting and high quality. But since of the time limitation, we only read some of it. But the other unanswered questions during this webinar will be sent. The answer will be sent by email to each participants that raise the questions. Okay, so I will read the first questions for Mr. Suroso, Pak Suroso. So the question from Mr. Ricky Adrian, he said that if the Jaffa Bali control center that has distributed control center combined into one main control center and one disaster recovery control center, what if there is an island operations? Is it still regulated by the MCC? And what if there is a cascading disturbance? How to handle it using the centralized or advanced control centers? Okay, Pak Suroso, Mr. Suroso, you may directly answer the questions. Thank you.
Okay, thank you very much. Thank you for the question, Pak Ricky. So the main driver of we are having the centralized control center actually to increase the effectiveness of the operation of the grid. So the question is whether is it more efficient if we are using the 5 decentralized incorporate into 1 control center. It will depend, but theoretically it will speed up the coordination between, used to be between area, but not only one single platform with several operators. So it will make a communication much easier. So if there is any event, contingency event of cascading trip or partial blackout on this particular segment of the system, and then the operator actually can enable recovery more quickly compared to the existing structure. That's one reason. Another reason is to utilize the common resources. In this case is, for example, like the analysis tool, the situational awareness tool, all the supporting software in order to enable dispatcher to react properly into certain disturbance. So in my view, if we are using the one main control room and using several functions integrated into one platform, and it will be manned by more than one person, of course, from the switching dispatching, it will improve the effectiveness of the recovery system. So that's my answer for the question. Hopefully, we can discuss more detail in other opportunity, Pak Ricky. Thank you.
Okay, thank you, Pak Suroso. Mr. Suroso, very complete and clear answer to Pak Ricky questions. So another question for Rob Hardison from NREL. So the question from Mr. Haryaji from B2B. From your experience, when you are talking about EMS upgrade, what are the main components that being upgraded? Besides the master station itself, do you also upgrade all the RTU and all the remote component in all substation in one time? So that's the question for Mr. Rob. Please answer.
I'd certainly call on the rest of the GPS team to help me answer that. Based on the interview that I had with staff at ERCOT, I think they would have said that it is generally driven by the time frames on the when those pieces of equipment will become obsolete, and on the contracts that are there supporting that in terms of maintenance. So I think that was a primary driver for the EMS replacements, was based on those contracts. But in terms of whether or not that covers entire systems or subcomponents of that, I think that depends on how those contracts are written up and how the procurements were done in the first place. But I would welcome the other answers from the rest of the GPST team.
Okay, thank you very much, Mr. Rob. Or maybe I think Kaiso just also upgrading the control center. Can you, Mr. Hani or Mr. Dede or Robert, can add another explanation for that question from Kaiso point of view?
I can. Go ahead, Hani.
Let me take a stab at it. Usually when you upgrade an EMS, you not necessarily have to upgrade RTUs. As a matter of fact, if the RTU is not obsolete, you upgrade the EMS and require the new EMS to be able to handle the different protocols for the existing RTUs. Now, in some cases, maybe what you want to do is replace the RTUs and the EMS, but that would be a little bit bigger project. it's usually preference to most EMSs can handle pretty much most protocols, and you can actually handle that much better. It simplifies a lot of things. So I wouldn't say just because I have to replace an EMS, replace an RTU. That is not really a must. Roberto, you might want to add?
Yeah, I have seen multiple EMS replacements when I was a consultant, when I was at Siemens, and in my professional lives. And I would say more than 90% of the cases, you replace the EMS and you do not replace the RTUs. The only reason why you want to replace the RTUs if it's you require a new functionality that you do not have at this point, or really is a very old technology, but they have their own life span, their own life existence. So I don't see the really a relation between you need to replace one and you must replace the other. I will not do that. And what Hani says is correct. I mean, the interface is normally protocol, and most of the system, or I would say, I will attempt to say all systems can handle all protocols existing out there.
Yep, I fully agree. The Taiso's, the points, and also I involve a few projects. For example, the ARCAD starts some EMS project in 2003 or 2000. That window to get that working, because that time they need to do some RTU testing. That's make the EMS project last longer than used to be. It's not just the EMS replacement 2 years, 3 years. Actually, that take a lot of the effort to test out those connection between the control center and the RTU and ICDP. So, yeah, I don't think there's a connection. You have to update impulse in the meantime, unless there's some functionality is not working.
Okay, thank you very much. Maybe Mr. Adrian want to add something? Adrian?
Yeah, I agree. I think I'm not sure if the question was the RTUs or the different modular elements. So I think if I was recommending the audience to study anything, I would definitely recommend that the Callisto architecture that Roberto presented on, where you had the enterprise bus and the different modules plugged in around that. So having a structure and architecture like that allows some flexibility in upgrading different elements of your design, your control center technology toolkit. So that might give some flexibility. Having a structure like that gives some flexibility to say, if you need to upgrade your, for example, weather forecast system or demand forecast or contingency analysis, you can potentially take that module, go ahead, go to market, upgrade it and plug it back in without having a full overhaul needed. So having that kind of modular structure, plug and play pieces, allows some flexibility in upgrades.
Okay, thank you very much. So there are some some answer from different perspective, from the system operator and also from the researcher about do we need to upgrade all component of SCADA system, because we have a master station, we have remote station, and we have link communications. Okay, so already answered by all speakers, I think. So the next questions, this is for the CAISO. In the free energy market, with significant portion of variable renewable energy or plants such as operated in CAISO, there might be need for import or export of energy with other interconnecting neighbor grid. Can we have a brief explanation regarding, firstly, hedging scheme of imported electricity from neighboring grid, if any? What is the hedging period applicable in the business and model of the contract? Second question, energy curtailment financial scheme in the imported energy and region internally produced electricity. Is there a penalty or energy balance scheme in the regards of energy curtailment? Okay, that's the question from from Pak Arif Susetio from the headquarter office. Please, Mr. Hani and teams from Kaiser.
Let me take a stab at both of them, and then I'll let Roberto elaborate, or Didi. CalISO have a balancing authority. We are a heavy importer for CalISO. We import up to 15,000 megawatt from external entities. But also we have hourly schedules, and we went to a 15-minute market. And that means every 15 minutes we can actually modify our intertie import and export dynamically. But because we have a market, the whole market is co-optimized for energy and ancillary services, respecting all congestions and flow gates. It's really one run that goes out and analyze and actually optimize import, export, generation, and balance everything all at once. And then we have day ahead and real-time markets. So the day ahead comes out with a solution every hour for tomorrow. Then the real-time optimize using that award and modify import and export as we go along. We also have a tagging system that automatically updates the tag and adjust according to the awards of the market. So we do have imports and export from pretty much all balancing authority, and we have close to 40 entities. And the energy imbalance market that we kind of mentioned early on have the ability to, each balancing area can actually do a dynamic import-export between balancing authority, and that goes down to a 5-minute. It's almost like a dynamic schedule that can be adjusted every 5 minutes based on award. So we pretty much balance the whole West, at least right now, 15 EIM entity, which is 15 balancing authority with CalISO, and all of these are one run every 5 minutes, and it can actually move electricity, import, export at any moment in time within defined limits and settle all of those and optimize it. I think if you look at our website, you can see we have crossed the $1.2 billion saving just from EIM. So that's on the import-export. We definitely have the benefit. And the fact that we have a big geographical area, it helps a lot. Where some area is renewable, you got sun, but another area have wind, another area have cloud coverage. So by having a big geographical area, you do benefit from diversity and a bigger footprint to help it. On the curtailment side is the other question, and I think the question is there penalty? Nobody likes penalty, but the way our curtailment happens, we actually have also structured curtailment depend on priority, or we do pro rata. So when we curtail, we actually curtail across the board, everybody on a tie according to their capability. I'm going to let Dee or Roberto elaborate also.
Go ahead, Didi. I think you're more versed into this. Thanks.
Thank you. So yes, so I think one of the comparisons that that often are forgotten is that California itself is one area that we are actually interconnected with AC system, the same frequency, with many other states within that Western interconnection. So to put into perspective, California ISO itself is about 50 gigawatt, about 50,000 megawatt. And then the interconnection itself is about 3 times bigger than that. So the interconnection is about 160 gigawatt size. So we do a lot of AC interconnection, just kind of like similar thing in Europe where you have actually AC interconnections, similar, with the neighboring. So we do that interchange, we call it, the interchange between California and all this other area. So when when oftentimes people hear about the number of renewable variable energy such as wind or solar, California ISO in percentage we have more. So for example, we have 12,000 megawatts of solar. When we talk about, we have 1,500 megawatt of battery. That's the big thing right now is the battery. That is only just for California ISO site. So the Western interconnection is actually bigger. So because of the fact that the system is large, we do benefit from that geographical diversity because the sun doesn't come at the same time in there. We have different time zone. So we do benefit from that. And all that to say that when you are creating an EMS system, and you are actually doing this economic dispatch, like an optimum power flow, we use the market system. And when we use the market system, it's really just security constraint economic dispatch, right? Just like an OPF. Those take into account of all those big, larger footprint. So we are benefiting from that larger footprint, and we do send dispatch signal to the renewable. So I think when we talked about curtailment, many people have this different understanding what curtailment means. So for us in our market concept, we actually have the concept to for people to bid, right? For people to offer, for people to bid, to say that, hey, I could be reduced, but you have to pay me for being reduced, for example. So there is what we call a decremental bid, where they bid to be decremented so that we can actually balance the system reliably based on a market application. So that's what we call an economic curtailment, where we actually curtail or reduce, but we actually pay for some of those curtailment to make sure that the system is reliable in there. The contract is a little bit different than what I am used to, maybe what I know of in Indonesia, than what it is here. So that's going to be another part of that items that allows how the tools and how the EMS and how the unit dispatch systems is being designed when it comes to how we dispatch the solar and how do we dispatch the wind, for example.
Yeah, just one little thing that I'd like to add in terms of designing the EMS. Years ago, you have a state estimator that runs every 5 minutes, and now we're going into 1 minute and 30 seconds. And it's for two things. One is the capacity of the new systems, but it's also the need to respond to variable energy resources. You need to respond fast. Your AGC cannot be 10-second AGC. It has to be a 2-second AGC or even a 1-second AGC, where you actually can send signals fast enough. When you talk about designing system, we used to have the term N-1, and that also refers to a generator, or it refers to a transmission line. I like to see at N-1 a solar, all cloud cover the entire island, for example. That's one N-1, and it's not N-1, it's N- a lot, but it's only one event that is happening. So a system needs to be designed to be fast and be able to respond, and also much bigger in terms of how many points and how many displays and how many data sets you need to have to be able to make the decisions.
Okay, thank you very much for the very interesting, detailed, and complete answer from the KAISO team. Okay, so we have one open mic questions for this golden opportunity. I let the host, Pak Haryanto, maybe you have questions or statement to deliver to the speaker after the presentations. Please.
Pak Dhani, mohon maaf, Pak Haryanto harus hadir.
Okay, sorry.
Closing statement nanti coba saya wakili.
Okay. So I think because of the time, ladies and gentlemen, so finally we come to the end of the webinar. Before I close this webinar, I would like to take the conclusion from what speaker has presented, that VRE implementations have to be supported by SCADA monitoring applications, enhanced communication infrastructure, historian system, AGC generator scheduling, and VRE forecasting tools. Dispatcher training simulator is needed as dispatcher exercise in controlling the power system. Embrace the future, the modern power system control for enabling clean energy transition. Jaffa Bali system prepare for the change of the future energy landscape in the Indonesia toward low carbon energy system by upgrading the existing Jaffa Bali control center become advanced control centers. So I'd like to thank the speakers from PLN, from KAISO, NREL, EPRI, and DIBAR for the fruitful, informative, and interesting presentations, especially for the GPST that makes this all happen, and all the audience for the very active participations. Finally, I would like to give big applause for the speaker and for all of you. Then I pass the stage to Ms. Mahani to close this webinar. Thank you. The stage is yours, Ms. Mahani.
Yeah. Thank you very much, Pak Dani, and all the speakers today for sharing your insight, knowledge, and your experience in such a positive way. Before closing this event, we would like to remind you again to fill the attendance list and feedback form via link which shared by our team in the chat box. Ladies and gentlemen, this is the end of our meeting today. And thank you very much for your attending and participation, and see you in the next series. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you.
Terima kasih Bapak Ibu.
Thank you, everyone.
Thank you very much.
Thank you.
Thank you, Mr. Hani.
Thank you.
Bapak, terima kasih. Manager team,
Thank
Bapak
you,
Ibu.
Rob.
Thank you, Kaiso team, for staying up so late and joining us.
Thank you, Rob.
Bye.
Thank you, Pak Dede.
Terima kasih, Pak Dede. Terima kasih banyak, Pak Dede.
Yeah, thank you, Hammi. Seong Choi.
Thank you.
Thank you very much.
Karena waktu
Thanks, Pak Dani.